Assalamualaikum and good afternoon. So I can't wait anymore because already 2:09. So how are you today? Puasa ke?
Alhamdulillah sir.
Puasa Alhamdulillah. Okay. So I would like to continue from the last Monday session. But before that, I will make sure you check in your attendance, and then we are doing some very quick revision about the design criteria. First criteria, the first design criteria, which is the design based on the roof space or land space. Okay, just the quick revision. So there will be the uh, two possibility whether it is arranged in lengthwise up or lengthwise across in order to fit in the roof or the land. Okay, there's an example. Okay, for the lengthwise up and lengthwise across, and the solution like we already learned before, just to arrange it upwards and the crossing from the left to the right of the roof. Okay, so this is the equation that we use, very super simple, straightforward equation. No Maxwell, no Thevenin, no Lorentz. Okay, a very simple equation. So in order to get the maximum number, just to make sure that all the items here, all the value calculated here must be rounded down. Okay, must be rounded down. All are rounded down. The logic is if you round up, so it will come out. The next model will come up here, so it's not the proper way. That's why we round it down by considering that not to install the extra modules. Okay, just to make sure that all our modules are fitted on the space of that roof. Okay, so that's the thing that we learned on Monday lah, as introduction for the grid connected design. Okay, so now we are moving to the next. I think no question at this level. No question Alia,
No, sir.
Ashifah.
Tak ada sir.
Tak ada. Okay. Alright. So if no question, then we move forward. Okay, we move forward. Oh, sorry, I forgot the base configuration one. Okay, the next also simple, and also straightforward. Okay, the system designer should consider all the various activities and items that incur costs. Okay, that's why the second criteria based on the budget. Budget, we're talking about the RM RM. Okay. So to make up a complete PV system, including consultation, design work to the PVCs, hardware equipment, inverter, PV modules, cable, solar meter, installation costs, the budak-budak that we use to install the install the solar module on the roof, for example. So the cost for that, labor cost also need to be considered, commissioning level, and all relevant costing, including the documentation of the PPA and so on. All the things are inclusive for this term of budget. Okay. So typically the size of the complete PV system is accounted for in terms of the installed price per installed PV. Per installed PV array capacity. In other words, there's a called F cost. So it's a cost factor for PV system RM per the kilowatt peak. Okay. Like I told you, maybe around RM 3 to 4K per kilowatt peak. Maybe that's the market value. I'm not sure. I didn't check for the latest one, but maybe within that region, okay, within the area of the cost. So you have the budget, and the supplier or the contractor or the seller or the agent will give you the deal of F cost. Okay, F cost. This F cost is based on a kilowatt peak. Every kilowatt peak kan. For example, you're quoting them. No, you're not quoting. You actually, when you say budget, for example, you are granted or you are awarded 100,000 ringgit Malaysia because you are very perform in your work. So the Minister of Finance, for example, they look at your performance specifically, and they would like to award you the 100k of ringgit Malaysia, but with condition that you need to develop the village, develop the place with the solar or renewable energy concept. Okay. For example, you are granted or the awarded with certain amount of budget, let's say 100k, and they just give the budget. So it's up to you what type of size that you are going to propose or you are going to present to the minister, okay, ministry. So then you are asking here and there, you are asking in the Facebook group, you are asking everywhere, maybe go directly to the company, knowing someone, asking for the quotation, full quotation per cost. You give them 100k, what is the maximum power they are going to promise us for the installation and so on, everything. So they charge it under the F cost. It's what we call F cost. Okay, F cost, all inclusive. Then after that, from the budget, then over the F cost, you're going to get the P array. Okay, what is it? Okay, P array. For example, 100k and the cost for per cost per kilowatt peak is 4k. Okay, 4k means that how much kilowatt? Maybe kilowatt. How much kilowatt that you are going to get? Berapa? 100k over 4k. Berapa watt?
25.
25 watt. 25 apa? 25 apa? Teruskan. 25 apa? Tak? Senyap lah dia. 25 watt peak ke? 25 megawatt peak ke? 25 kilowatt peak ke? Which one? What 25?
Kilowatt peak.
Kenapa kilowatt peak?
Sebab dia pakai dalam kilowatt peak.
Because the cost is written in the per kilowatt peak kan. So that's why you get 25 kilowatts. Oh, sorry. 25. God. Okay. So you're going to get 25 kilowatt system. Okay. Kilowatt peak tu refer to the PV installation. PV PV dia panggil KWP lah. P tu peak tu refer to the PV. Kalau if wind, I think different. Kilowatt maybe only kilowatt. If the expression of the apa kita panggil genset size ke apa ke kVA, contoh MVA atau kVA kan, that kind of thing, generator. For this case, so the answer 24 kilowatt peak very straightforward lah. Okay, so this is the budget, and let's do some example. Example 1 tak ada. Saya perasan example 1 tak ada. Oh ada. Okay, sorry. Okay, example tu, let's say, okay, macam hantar Chai Kuan J. Okay. Still intact? Yes. Divania.
Yes, sir.
Okay. Sleeping already?
No, sir.
Okay. Wait, stay awake. Alright. Okay.
Yeah.
Let's proceed. Okay. So let's say we have this kind of example. You are given budget of 36,000 ringgit Malaysia. Someone give you a gift, 36,000. We also hope that we get this kind of gift, not from Aishitra but from somewhere lah. from the dermawan. Okay, so then the recommended PV module maybe because due to this suggestion from the contractor or the seller or the agent of the solar company, so they recommended PV module brand Iman, my brand, my brand, very high quality brand. Okay, with the 240 watt 1S and the Pmax is 240 watt, IMP 8 amps, and the VMP is 30 volt. So this only for the brand Iman, from brand Iman from Pekan. Okay. So they don't want to suggest you the Yingli brand or the Panasonic or the Sun Power because they trust more on brand Iman. Okay. Then the PV costs all included. That's why the price is slightly expensive than the market value, but they promise you the best service they will give, the best workmanship, the best service, the best finishing. That is what they promise you lah. Okay. So the question is, what is the maximum numbers of modules that can be installed? Very straightforward and super easy for them, for me lah. Very straightforward and extremely super easy question. Maybe because of the example. So the task is, what is the maximum numbers of modules that can be installed in that proposal lah. We're not sure in the roof or whatever, we don't care. What we care is about the budget that we are given, 56,000, and the brand Iman module, very high quality that we are going to supply to you. Okay, so the maximum number of modules, very straightforward. So P-array STC. So first of all, you need to calculate P-array STC. We have to know what is the maximum peak power from PV that can we install based on our budget. So very straightforward, 36,000 over 4,250 ringgit over kilowatt peak. Then you are going to get 8.4705 kilowatt peak. So this is the P-array STC, standard test condition of the P-array. Okay, power of the maximum power of the STC condition of the maximum power for this array. See, now we know already the kilowatt peak. So what's next? They're asking you what is the maximum numbers of modules that can be installed. So what is the solution? After we get 8.4705, what should we do? Hasif.
Yes, Doctor.
What should we do after this? Where should we go? What should we do?
Ini bahagian Doctor.
Bagi dengan?
Bagikan dengan dia apa?
Teka je.
Yang tu kot, recommended PV module lah Doctor.
Ulang balik, tak dengar. Ulang balik.
Kena bagi dengan recommended PV module.
Memang. Kau kan saya cakap tadi, I told you just now, you cannot buy other brand. You have to buy only this one.
Bagi
You
dengan
only give me this choice. You don't give any other choice.
240 tu.
So bagi dengan apa?
Bagi dengan 240 lah.
Okay. So we are going to divide the module and reflect to this 240 lah. So we are going to divide with the 240 watts in order to get the maximum number of modules. So P-array STC over PMP STC. So this is the maximum numbers of the module. So simply this kilowatt peak over 240 watt. Then you're going to get 35.2937. And then for this case also, it is rounded down. My question, the same question, why it is rounded down? Nurul Ain Izzati. Ya, Muzammil.
Doctor, it is rounded down because of the size. If we extend the size, it will go outside the specific area we may use.
Okay, you mean because of the size, that's why we round down for this case?
No, according to the given space we calculated to minimize the error of breakage of our solar panels. That's why we round down instead of rounding up.
Okay. No. The reason is not about the PV module. The reason is not about the PV module. We don't care about the size of PV module in this case because maybe because we are not detailed what is the size of the module, but it's okay. It's good. It's a good try. But the first criteria would be based on the module size and the area of the place to be installed. For this case, it's slightly different. It's still round down, but the explanation is slightly different. Nurul Ain, dah hilang ah. Oh, tadi ada. Dah gaib. Mardiah.
Yes, sir.
Kenapa? Round down.
Tak sure lah, sir.
Try lah. Tak nak try?
Sebab senang nak ikut saiz bumbung kot.
Ulang balik. Senang nak emphasize.
Bumbung.
Bumbung.
Okay.
Okay, bumbung juga ada main. Okay, tak apa. Good try, tak apa. Farhana.
Yes sir, sebab tak nak lebih daripada saiz.
Tak nak lebih pada size apa? Size apa?
Area.
Tak nak lebih daripada size area. Sekejap. Tak nak lebih size.
Tak nak lebih daripada area yang provided.
Okay, maksudnya size area provided lah. Walaupun tak mention berapa area. Tak apa. Good try. Sama macam Zamir kat lah. Sekejap Fahim Nazmi. EA19031. Fahim Nazmi. Penuh sebut.
Yes, sir.
Why? Why is it round down?
Because it doesn't want to go over the size area.
Oh, sama juga macam tadi lah. Doesn't want to go over the size area, I mean the roof or land like that. Betul?
Yeah.
Okay. Tak apa, saya tanya orang lain.
Sir.
Ya, okay.
Nak try boleh tak?
Boleh try. Kita jantan.
Nak, kalau tak lebih bajet,
Setuju.
Yes. Because you are given 36,000. If you round it up, it becomes 36. You can still install that, but the 36 module, you use your own money. Macam tu. Understand the reason? Because of the budget. We are limited with the budget. The budget is given 36,000. If I round it up, and 36, maybe it will cost you 37,000, for example lah. Just an example. 37,000. You can still install it, but you need to use your own money lah. Your pocket money kan. So means that we are restricted by the budget. So that is why the maximum number of modules that can be bought or installed with that 36,000 because of the budget. The budget is 36,000. That is why round down. Okay, if you round up, you need to add another extra money. So because we want to stick with the 36,000, it is round down. That's the answer. Boleh, Owi?
Boleh, doktor.
Cepat respons. Bagus, responsif. Tak tidur maksudnya. Bagus. Okay, boleh. Any other question? Yang tak puas hati. Siapa yang tak puas hati? Okay, Muzammil.
Yes, doctor.
Okay. Alright.
Yes, doctor.
Budget. Alright. Okay. If no question, then we proceed to the next criteria. Okay, the next criteria. What is the next criteria? Okay. Designed to meet yearly energy requirements. Okay. For the case of meet yearly energy requirement, or we call that as we also call as the annual yield. Annual yield. Okay, annual yield. So this is the most, in terms of calculation, the most complicated lah. I can say that not that complicated, but it's longer lah. The solution is longer than the first and the second criteria. Okay, in order to design the mid-yearly energy, because there's a lot of things that need to be considered. Okay, so we need to consider the subsystem losses due to the following. Means there's in one system, one PV system complete, there's a loss. But there's a small part, the things that also mean the small part mean the subsystem lah of the full, from the full system, the subsystem, there's losses also that need to be considered. There's a part that we need to consider this kind of loss before we accurately predict or estimate the annual energy yield. Okay, annual yield, energy yield. What are those things? First of all, the things that we have to consider after this is the inverter efficiency. The difference in the efficiency of the inverter will totally reflect to the output of the our PV system. Okay, that efficiency is critical when you are going to install a mega scale or the large scale solar SSS size of the system. So it's really affect that. Okay, so choosing the inverter with the highest efficiency is the most desirable one. Okay, mean that the highest is desirable lah. On what level we call it as the high efficiency? 98, 97, 98.5, 98.7, even above 95 also we consider efficiency. But recently I think I found 98.7 highest efficiency. For example, if input 100 watt, the output also 100 watt, that kind of thing lah. Whatever they get, that's the thing they produce. Okay, 100 watt, 98 watt coming out. So that is 98% efficiency. That is the meaning of that. Okay, so the inverter efficiency you can't just simply buy from the internet, click, use Shopee Pay for example, and just bought because it's cheaper. No, you need to be very sure that the brand is well established, they have the data sheet, and the data sheet is correct, and they have expert, you can contact them, something, because you are playing with the high scale. Grid connected, you cannot playing just like that lah. Everything must be original lah. I mean the brand must be original lah, not the pirate one. What's next is the cable losses. Okay, cable losses, transmission efficiency. So that is the longer the cable is, the higher the voltage drop can become. Okay, the higher the possibility of the voltage to drop. Okay, shorter cable is desirable lah, of course, but certain cases, if you have the mega scale size of the solar farm scale, we can do the 10 meters only cable. You need to have 100 meters of cable or maybe kilometers of cable. If you add all the length of the cable for all the modules for 50 megawatt size, it will be more, several kilometers maybe. Okay, but this thing also you need to consider the cable losses. Cable losses comes from the voltage drop. Okay, it reflects to the MS 1837 2018. The maximum allowable voltage drop is 3% on the latest one. On the old one, 2010 is 5%. So the voltage drop, allowable voltage drop is 3%. It reflect to the voltage drop. Okay, voltage drop. Okay. What's next? Average yearly irradiation for selected angle and orientation. The important thing here is the irradiation. What is the irradiation? Is the peak sun hours. Okay, peak sun hours that I told you roughly for the rough understanding of the peak sun hours. What does that mean? Every day we need minimum 4 hours of consistent 1000 watt over square meter equivalent of the solar irradiance. So that's the target. Means every day, one day, 4 hours, months, 120, year, 1,440 hours. This is the rough one. But the real one, it can become 1,500, 1,700. This kind of data we can get, if you use the PVC's one, you can get interpolate data. They have the interpolate data. So you can get how many peak sun hours per year in 1 year on that specific place, specific location. Okay. So the irradiation, the more irradiation you get, the more energy that we will generate. That's logic. Logic. So other than shading, we are not talking about shading yet, but shading also coming for the irradiation. If the good irradiation, but you are covered, you are surrounded by the nearby buildings and trees and forests, high building, lot of shadings there is still not applicable or suitable for the PV installation. Okay, even though you have the irradiation data, but still the effective irradiation will be deducted from the shading, total shading of that particular area. After you do solar pathfinder or the sun eye, then you're going to deduct if there's some shading. The ideal one is to the place that very open land or on top of the roof that are no nearby tall buildings that can block or create hotspot on your modules or PV string. Okay, so irradiation. That's the third factor. What's next? Next, advanced manufacturing tolerance of module and mismatch. Manufacturing tolerance of module and mismatch. This will reflect directly. You only can know this value from the PV modules datasheet. The same datasheet that you refer in order to know the value of VOC or the ISC or the PMP or the temperature coefficient or the NOCT. The same datasheet, you are going to get what is the manufacturing tolerance for this module. Later, I will teach you how to extract that. Okay, that manufacturing tolerance, the value in the datasheet. Usually, it's written in the plus and minus. Okay, plus and minus. For example, I give you example, 3%. Plus and minus 3% of the tolerance. Okay, there's another words also. Manufacturing tolerance, power tolerance, tolerance. As maybe the way to track it, usually they just beside the very near to the value of the PMP in the datasheet. They written plus minus 3%, sometimes 5%, sometimes plus 5% minus 0. Sometimes they have also that kind of values. So this value also we need to consider in this calculation in order to solve for the third criteria solution. Okay. Next, temperature effect. Okay. Temperature effect, we are going to use the temperature coefficient factor. The F-temp. The original equation from the corrected one. 1 plus PMP T cell minus TSTC. So this is the value. Okay, this is the value of the temperature effects. Okay, so the next factor, the fifth one is coming from the temperature coefficients. The value from temperature coefficient we get also, we are going to proceed with this temperature effect factor. Okay. less effects of dirt on the module. We call that as the dirt factor. Okay. Dirt factor sometimes it depends on our question. Can become 3%, 5%. Worst case can go to 10% for the desert place. I mean like the Sahara, okay, like the canyon, that full with dust. At the time, the dirt factor are higher, than the normal place for the PV installation. Okay, so these are the factors that need to be further detailed and considered for the case of the third criteria, that design the PV system based on the dedicated annual energy yield. Okay, annual energy yield. Boleh Syuhada? Boleh ke Syuhada?
Boleh.
Boleh, kejap aku. Okay. Alright. Mana? Dua ni. Okay. So I am going to derive the equations for that. So we are going to go one by one. We are going to proceed one by one until we derive all the equations. They are related for these third criteria solutions. Okay? Okay, let's say we have PV array, or regardless whether PV strings or PV array or PV modules or solar farm, whatever. So we have PV modules. Okay, PV modules means that more than one modules. Okay, more than one module. We don't play with the single module. When we go for grid connected, of course, we are play with the kilowatts or megawatts of size or gigawatts of size. That's why there must be modules there. Okay, then there's a highway between them, between the inverter. We have the inverter. Our destination is the inverter. After the inverter, they will go to will export all the generated energy to the electricity provider, or the grid one. For this case is TMB, or the client. The client is TMB because the purchaser is TMB. TMB purchase the energy, purchase the generated energy that we generate. So they buy from us. Okay, they purchase from us. Right. So between the module and the inverter, of course, we have the highway. We call the DC cables, of course, because PV system is DC based. Until the inverter. After the inverter, it will invert to the AC and it exported to the TNB grid. Okay, it's clear. Okay, means we have PV modules. Okay, PV module we have DC cable and we have inverter. So all the equation will be related to these things. Okay, first of all, when we have the PV modules, we are going to have the value for the P array STC. Okay, how many modules you have will reflect to the how many PV array STC lah. Because each module, if we have the 10 modules, 240 watt per module, so 10 modules equivalent to 2.4 kilowatt or kilowatts of power. Okay, kilowatts of power. That power is the P array STC. Okay, so from the PV modules, we have the P array STC. Alright. So the P array STC is equal to the P module STC, or the PMP STC is the maximum power point, standard test condition of the maximum power for the module. It's also called as a PMOD STC lah. Ni PMOD STC, peak rating of the PV array at STC. Peak rating, no, ini mode. Peak array of PV module. Sorry, module. Okay. So the P array STC is the P module multiplied with total numbers of modules. Okay, total numbers of modules. Okay, so that we get the P array STC. If 20, then 20 lah. 240 multiplied with 20, you get 404.8 kilowatts. So that is the P array STC. Alright. Okay. On top of the P array STC, or on the P array, on the PV module itself, there are several factors that we need to consider. Okay, what is that? First of all is the FMM. What is FMM? FMM is the rating factor for manufacturer tolerance and mismatch. It comes from the tolerance or power tolerance or the manufacturing tolerance that can be extracted directly from the datasheet. Like I told you, maybe it becomes plus minus value 3%, for example. So the rating factor for the manufacturing tolerance for that case is the 3%. Okay, 1 minus 3%, you're going to get 0.97. So that is what you call the rating factor. But it's okay. After this, you are going to do one exercise. InsyaAllah, you are going to be very clear after that. Okay? But first we go with the equation. Boleh? Syahmi, Hafiz. Boleh, Syahmi, Hafiz. Jeng. Nizaruddin.
Yes, sir.
Boleh? Kita proceed
Boleh.
Cakap boleh je. Okay. So, we have manufacturing tolerance that need to consider. Is originally based on the fabrication one. I mean, manufactured already, they already have this kind of rating factor lah. FMM. Next, FTEM. We know already FTEM coming from the rating factor for temperature, the FTEM. Okay. The things that comes, the 1 plus 1. 1 plus gamma, PMP, multiply T-cell minus T-ST, that's the thing. So that's the the FTEM is calculated based on the equation. Okay, the FTEM, second one, because the temperature, temperature effect. Alright. Next is the F-dirt. Okay, F-dirt, usually in question we state just like that, 2%, 3%, or 4%. If 2% mean 1 minus 2%, you get 0.98 is the rating factor. Original value is 1, but after considering the factors, so on, percent, everything, so it becomes 0.97, 0.8, like that. Okay? So the next equation is P array. Okay, after considering this factor, base the original P array STC, then you can calculate the P array. So the P array is derived based on the P array STC and FMM, FTEM, and FDIRT. That's why we come like this. So the second equation is here. P array STC multiplied with FMM, FTEM, and FDIRT. So this is the P array. Okay, the equation for the P array. Okay, what will happen after next? Okay, now we have the sunlight. We have the sun. Sun is our friend in order to generate the energy. So we have the sun there. So what is the sun there means that the PSH per annum is the same like the yearly irradiation. So how many thousands of hours that we are going to obtain for that year. So that's why PSHP is equal to the PSH for the specific angle over 1 year lah. It's the per annual PSH. Okay. So we have the P array already. Then we get the PSHPA already. Okay. What is the value for the PSHPA? Hours, Hours. So, this is the P array in watts. And then we have the PSHPA in H, in hours. So, what we get here? Nuraini macam nak cakap. Ada soalan ke, Nuraini? Siti Nuraini, okay?
Okay, sir.
Alhamdulillah, syukur. Okay. Alright. So from the PSH hours and the P array watt, we can see the combination of watt hours there. So what is that actually? Is the EPV. What is the EPV? Is the generated energy through the PV module sites. Through the PV module sites, the expected generated energy is EPV, defined as EPV, where the EPV is equal to the P array multiplied with PSHPA. Okay, P array multiplied with PSHPA. So that is the total of generated energy through the PV module site. Okay, only for the PV module site, is not transported to the inverter yet through the DC cable. So it's in the side of the PV modules. Okay, PV array. Then we get the EPV equal to P array multiplied with PSHPA. Okay. Next, okay, after we finish on that side, so we are going to the next place with the inverter. During the inverter, we have the highway. On the highway, we have the toll, because not any other place. Every government desires for the toll. So we need money from them. Okay, no, just that simple analogy. So there's a toll there. What is the toll that we get here? If you see the flash here, this flash sign, this is the not N, is the efficiency. The symbol for the efficiency, PV to inverter. PV to inverter. What is that? Is cabling efficiency between the PV and the inverter is reflected to the voltage drop. When reflect to the voltage drop, so it plays with the MS13837-2018, which is the maximum allowable voltage drop is 3%, maximum only. Max 3%. All stuff, 2010 Malaysian standard is 5%. But we don't use that again. Now it is decreased to the 3%, which more optional. Okay. So then we have that. The efficiency from the PV to inverter, which is the voltage drop that reflect to the voltage drop. So the derating factor from the voltage drop. Okay, so that's the thing. After that, we have another flash sign, which is the inverter efficiency. Okay, this will totally depends on the brand. For example, I just take up from the internet. This is the Fronius brand. Okay, not the Huawei one, it's the Fronius one. So the Fronius one, for example, produce 96%, for example. So that is the inverter efficiency. From there, we have another definition of NPVSS. Don't ask me what the SS, I just following the book, the old book of the SEDA one. So that NPVSS is just the multiplication between the inverter efficiency and the efficiency, cable efficiency from PV to inverter. Then we get, cannot see here. So PVSS equal to PV inverter multiplied with the inverter efficiency. Then we get this value lah, combination for this, derive. After that, after considering all the derating factors that coming from both sides, which is modules, highway, three sides, modules, highway, and inverter itself, the net energy that come after deducted all this parameter is defined as the E system. Okay? Energy system. E system. So what is the E system exactly? E system is the EPV multiplied with the inverter efficiency multiplied with the cabling efficiency. Mana ni? Ni. So this is the final output, the system, E system. Okay. E system. So this is the last. Okay, the last. Okay. So the E system is derived from the EPV multiplied with the efficiency of the PVSS, and the detail for the efficiency of the PVSS is reflected coming from all the FTEM, FMM, FDIRT, P array, STC, PSHPA, and so on. So this is how the logic of the derivation of this equation for the third criteria. Okay, if we reflect to the question, you are given certain amount of energy. Sometimes, I tell you, sometimes the question can ask in a different way. Yeah. But embedding storage battery with solar panel is not cost effective and efficient enough. Embedding. Okay. You have to understand this one. For the grid connected, we are not going to put any storage batteries. So the issue of storage batteries are not included in the design of grid connected. It's only reflected to the standalone PV system. Okay, we have only inverter and PV modules only for the grid connected PV system. So embedded storage battery, solar panels is not cost effective. Grid inverter are more, I believe the grid inverter are much more expensive than the standalone inverter. Okay, the standalone inverter usually are more affordable than the grid inverters, because the grid inverter, they have the protection. They have to be very sure. They have to align with the frequency and the voltage, appropriate frequency and voltage with the grid. So they have to sync. So that sync and protection, that's why the price for the grid inverter are by far expensive than the standalone inverter by general typically. Okay, Muzamil, the storage batteries is not, we are not included the storage batteries in the grid connected. You are not allowed to put the batteries in the grid connected system. But for the self-consumption based or the PV system, that is different. That is different structure. That originally come also from the standalone. Okay, when we talk about batteries, that only applies for the standalone PV only, not for the grid connected. Okay, Muzamil? Alright? Okay. It sounds very far, your voice, but it's okay. I can hear. Alright. Mana ni? Okay, any question? At this level, any question? Zulfikar.
No, sir.
Ada soalan?
Tak ada.
Ada. Okay. The question can ask you, for this case, we are finding the energy system. So that energy system is actually the energy requirement. It's also the energy yield. It's actually the energy yield lah. So this is the value of the megawatt hours that I told you before. The target of the megawatt hours that you need to supply to the electricity purchaser, to the client, which is the TMB grid. So this value you need to deliver. If you don't deliver, this is what I told you, you are going to be penalized. So this value are the targeted one. So you have to make sure that the value is achieved. Okay. The question can ask in the opposite way, because in this example, because I derived the equation from the 0 to hero, 0 to hero. The question can ask in different way. For example, we set the 100 megawatt hour. That's the target. By who or by crew, please propose how many modules, what is the maximum number of modules that need to be installed. So that is the question that can be asked. So they're asking you in a different way. So I just rearrange the parameter just to take out the end total, because most question can ask you what is the number of modules required. What is the number of modules required in order to deliver the 100 megawatt of energy per year. So that's your target. Then you start to calculate. So that value, each system is the now 100 megawatt hour. Understand? From here, we find in a different way, we are going to take what is the number of modules that are required to deliver this 100 megawatt hours of energy yield. So I just rearrange the equation. So this is the equation after it is rearranged. Okay. Okay, last we are going to do example 3. Then I promise we finish because I cannot proceed with the next one. I think we need to stop here. Then we do some exercise. Or we first focus on the test on the next Monday. So for this example 3, we end here. And then next Monday, you're going to do the test. Okay? So let's do the example 3 to better understand. Yes.
Betul, saya ada soalan nak tanya sikit. Untuk cabling efficiency tu, macam mana kita nak tahu ni tadi?
Macam mana nak tahu? It is given. The value is given.
Oh, given lah. Kalau let's say tak given, macam contoh kalau kita buat daripada supplier ke benda tu.
Okay, kalau value not given, kita ambil worst case 3%.
Worst case 3%.
Maksudnya maximum allowable voltage drop is 3%. But if you target 1%, 2% in the design, you set 1%, 2% lah. But kalau in assignment ke, kalau the value is not given, you can assume the maximum one is 3%. 3% is the maximum one. You cannot put 4% or 5% because it's already over the standard, given standard. Okay. Let's try to do the example 3. Okay. This time we give you a lot of parameters. Okay. But we haven't gone yet to example of the PV modules, datasheet and so on to show the values. But we do the example 3 and I hope at this level you know at least the calculation, what is the parameter related. Then after that you're going to extract manually from the datasheet. Okay. Let's say question. Oh, sorry. Question dia maximum number ni. What is the maximum number of modules? Okay. Right. Okay. You are given energy yield. So this is the target. This is the target of energy yield. Okay. Then you are given the annual peak sun hours. What is that? Okay, I'm going one by one. Okay, this is a PSH PA. Not the 1,440, it's the 1,720 hours per year, for example, at certain location. And then solar irradiance is given. Instantaneous solar irradiance given is the expected, maybe overall average irradiance, typical way. We don't assume the 1,000, we just assume we put the 800. There's a use of that. Okay, after this. Alright. And then the ambient temperature is given, 32 degrees C, and the depth factor given 2%. Voltage drop is given as 3%. Okay. Then PV module as usual, you have a very good contract with the brand Iman. So we need to stick with this module only. Okay. Cannot move on. And then they are given you the temperature coefficient of the PMP with the value of typical, I think for monocrystalline maybe, minus 0.45% per degree C is the temperature coefficient of the PMP for the brand Iman. Okay, for brand Iman. Alright. Next is the tolerance. Tolerance is given as minus 3% plus 5%. And then the anosity is given as 47 degrees C. Okay, 47 degrees C. And then, so this is all the values that I purposely put in the slide so that it's easy for you. You don't have to extract from the modules datasheet. Okay. So first of all, what should we do? The equation that we are going to use is not the first criteria confirm. It's not from the F cost, the second criteria, but it's the third one, which is the latest, the N total. So I give you the equation only. N total equal E system P over P mod STC multiplied by PSH PA and F temp, and then FFM, F dirt, efficiency, cable efficiency, and the inverter efficiency. Okay. So what is the value of the E system? What's the value of its system? Christopher. Christopher. Amir Aizat. Tak ada orang?
Dia saya.
Ha, ada pun. Mana je saya tadi? Wow lah. Lah, Lezal, kau menjawab. Aku tanya Amir Aizat. Ke dia ada dalam tu?
Saya kat sebelah dia.
Oh, ya ke?
Ya.
Bersekedukan ke? Ya, okey. Apa? E-system tu berapa? Cepat.
E-system
Rizal boleh jawab ke? What is the value of E-system? Which one?
Ni lah, 10 tu. Di atas kiri tu.
Jelas sikit, tak dengar cakap sore.
10 megawatt tu.
10 megawatt hour. Kena confident lah sikit. Sebut.
Tak confident tu.
E-system sama energy. Kena confident. Buat design warna nak convince klien gini. E-system.
Betul.
So E-system is 10 to mega kan? So 10 to 10 power 6 lah. Okay. Next,
Sir,
what?
sir.
Yeah.
Soalan apa? Max number of
Sorry.
apa?
Allah, sorry. So nama modules. Sorry, modules.
Okay.
Allah, sorry lah. Sorry. Tulisan doktor itu lah. Okay, what is the value for the PIMO STC? Aziz Syauki.
Dia Dr. Zahan.
Kejap more.
E-mode STC lah kan?
Yes.
240 watt.
Yes. Betul. 240 watt. Okay. Next, PSHPA. Nurwani. Nurwani Ahmad. EA19027. Sebut penuh. Ada? Tak ada. Ezzuddin.
Ya, doktor ada.
PSHPA berapa?
1720.
Betul.
Oh,
1720 hours. Okay. Bagus.
betul.
Okay. Next orang. Orang next. F-Temp. Owi Safika. F-Temp macam mana?
32 degree Celsius ke doktor?
Apa? Ulang balik?
32. Kejap.
F-Temp ni kena kira. F-Temp dia ada equation tadi. Sini kot. Okay.
Tak pasti doktor.
Tengok kanan tu. Okay.
Oh.
F-Temp. Okay.
Tadi.
See here. F-Temp equation yang kita belajar sebelum ni. 1 plus temperature coefficient of the PMP. T cell. This is T cell. This T cell minus TSTC. So the F-Temp is, you need to calculate lah. So you need to calculate the T cell as well. Then use the equation of temperature correction factor. Okay, temperature correction factor. Put all the values here. So that's why, for example, this value is put here. Okay. T ambient is 32 kan? T ambient is 32. NOCT is given 47. PMP minus 0.45. Okay. Then you are going to get 0.847 for the F temp. Boleh Awi?
Boleh doktor.
Macam itulah. Begitu. Okay. Kita tekak ni. What is the FMM, which is the directing factor of manufacturing tolerance? Izzat Imran.
Yes, doktor.
Macam mana dapatkan FMM?
Negatif 3, doktor.
Negatif 3. Kejap. Sebab dari mana? Kau dapat mana ni? Oh ni. Okay. Sekejap. Okay. Lupa nak sebut. FMM dekat sini dia ada dua value. Tolerance ni saya cakap ada plus dan minus. So which value that we are going to take? So awak cakap tadi apa? Awak pilih mana?
Negatif 3.
Why? Negatif 3. Tanya terus. Tak cakap je. Why not plus 5? Fikir logik.
Apa itu dalam persen?
Ulang balik.
Tak ambil 5 sebab 5 tu dalam persen.
5 tak, dua-dua pun dalam persen ni. Okey, aku betulkan balik. Sekejap, dia sini. Dia dalam kurungan sini. Dua-dua pun both are percent. Means one is minus 3% and the one is plus 5%. Okay, let's say we choose the minus 3%. The reason is why? What is the reason?
Tak pasti lah, doktor.
Tak tega. Tak apa, saya tanya lain. Khairul Nizam. Muhammad Khairul Nizam. Ada. Muhammad Yusuf. Ada Yusuf. Why we choose the minus 3%? Why not plus 5% for the manufacturing tolerance? Why? Teka je.
Sebab voltage drop je.
Ulang balik.
Voltage drop je.
Dia bukan voltage lah. Dia bukan voltage. Tapi dia power drop.
Power drop.
Tolerance tu daripada power. Tolerance coming from the power tolerance. Manufacturing tolerance. Tolerance is about the power itself. So power drop. We consider only the drop of power. And increase of power tak ada issue lah. Kalau 5%, Alhamdulillah. Betul lah. Kalau dia plus bagus lah. Yang kita consider worst case. Worst case is the minus value. That's why, please take the value of minus with the minus sign. Sometimes they're giving you minus 0 plus 5. So for this case, kita ambil yang mana? Ridwan Arif.
5. Kod.
Tiba 4 kau ni. Sekejap dia sini. Minus 0 or 4 plus 5%. So kita ambil yang mana? Untuk consider manufacturing tolerance ni?
0.
0, yes. 0. 0 mean perfect perfect. I mean this module are perfect. There's no power drop. The power is maintained. Minimum tolerance is 0, means perfect But it become plus 5%. Easiest word to say for 240 pi Okay, let's say what is the meaning of tolerance? Okay. Tolerance mean the value, the varies of the values, the varies of the when at the peak condition or the STC condition. Okay, let's say we test the module in the STC condition 1000 watt over square meter, T cell 25 degree C, and AM 1.5. The target of module is 100 watts. Okay, this is 100 watt. But because there's a plus, minus, or 3, okay, let's say we ambil plus minus 3% and plus 5% means that the value will vary minus 3, 77 to 105. Varies. At the peak time, they cannot exactly stay at 100 watt. Of course, logic. But they have tolerance, negative, plus, minus. So that minus will drop until 97 only. The plus 1 will rise until 105. The constant that we need to be very careful is the minus 1 because they drop. So that's why we're taking the minus 1. Bukan minus 1 nyanyi tu minus 1 tu maksudnya 97 lah. So in this case, we are taking the value of minus 3%. So the second equation, how to calculate that is the 1 minus 3%. Not the 0.03, remember because the perfect marks is 1, there's the drop. So we consider only percentage. So the value that replace the MMM, okay. So this value is not 0.03, but it's a 0.97. Okay, 0.97. Alright. Dead factor. How much is the dead factor? Roger Gun. Roger.
Yes, sir.
What is the value for F dead for this case? F dead. Right. Come on, Roger.
0.02.
0.02 is the dead factor. Okay. It's the same case like ni. FMM also, concept. So what is the F dead? 0.02 is the dead factor. Dead factor is 2%. That is the 0.02. But the F dead, how much is the value of the F dead? The same concept with the FMM.
Not sure, sir.
Okay. Minus. Okay, you just minus with the 0.02, you're going to get 0.98. Okay. We deduct the value of 2% here. Okay. 2% is here. So the F dead, you're going to get 0.98, not the 0.02. Because we are deducting the factor of the dead. That's why this F dead FMM is the derating factor. So the full mark is 1, then drop percent, then becomes that value. Okay. Alright. What about the cable efficiency? Rizal. Tanya Rizal lah.
Ya.
Cable efficiency. Tadi dia tanya ni kan. Tambah Z. Tanya kau juga. Ni.
Efisiensi
Ni.
Alamak.
Dia
macam kena cari ya, Doktor?
Ya, kena cari. Tapi same konsep dengan equation number 2 and number 3. Konsep sama.
Konsep sama. So kita ambil pada voltage drop tu.
Ya.
Satu tolak dengan 0.03 dapat 0.97.
Mesti ambil PSM dengan lecturing yang berkaitan
Alamak.
Okay, 0.97. It's 0.97. Kita deduct daripada voltage drop. Okay. Sama macam F dead daripada dead factor, FMM daripada tolerance. So we are not, the value is not 0.03, but it's 1 minus 0.03. Okay. And then inverter efficiency. Tanya siapa ni? Kita tanya Hafizah. Hafizah. Nur Hafizah Ali. Tak ada. Syahrul Aiman.
Ada Ustaz. Ya.
Mana? Apa inverter efficiency? What's the value of inverter efficiency?
Yang Pmax tu
Tak.
Kena kira asing tu daripada Pmax.
Tak. Inverter efficiency usually you get from the inverter lah. Tak tahu?
Tak.
Okay. Jawapan dia, the answer is, I'm not giving you the inverter, the value of the inverter efficiency here. Memang tak ada, it's not included here. But, if the inverter is not given, assume 0.95. Okay, ini memang in the SEDA, they are written there. If the inverter efficiency is not given anywhere, sometimes they are not given in the questions. At this time, you assume the value of 0.95. Okay? 0.95 is the assumed value for the inverter efficiency. Saja tanya tadi. Sebab memang tak ada pun dalam ni. Ni memang dalam SEDA guideline, they assume 0.95. So, if you do the full, if you write the equations, all the equation, or we put all the values here, then this kind, you get this kind of value lah. Okay, this kind of value lah. So where inverter efficiency is purposely not given. It's purposely not given. That's why you assume 0.95. Boleh, Siti Fadilah?
Boleh, Doktor.
Baik, bagus, responsif. Okay, please calculate how much is it? How much the value for the n total?
31, sir.
Berapa? Full number with the decimals.
31.78969.
Lain ni.
Saya dapat sama dengan doktor.
Macam mana tu? Ya tak, Rizal? Betul ke?
Ada.
Kau nak
Betul, saya dapat sama.
2.65. Tak orang lain dapat ke?
Betul Ustaz. 2.65.
Ganesh dapat Ganesh.
Dapat saya, dapat sama dengan saya.
Sama mestilah sama dengan saya. Kalau tak sama saya.
Amirul ni kau buat pandai ni.
Amirul dapat.
Alamak, kau mat.
Amirul cuba kira balik. Dikalkulate.
Dapat.
Dapat, alhamdulillah, syukur. Okay. What do we do next? As usual, we cannot leave because they're asking the question, what is the maximum, what is the modules? What's the number of modules? Maximum module pula. What is the modules? What is the number of modules? They're asking you how much is the module lah? How much is the modules? In order to achieve this kind of criteria, so what is the number of modules? Okay, here we have the decimals, so you cannot leave it in the decimal point. Of course, you have to proceed to the next step. So Ganesh, your answer 32. What about the others?
32, kena round down.
32.
Round down sebabnya first second round down macam tu
Budget siap.
Budget. Follow macam budget tadi dah, konsep macam budget tadi dah. Betul? Okay. Lain. But they're asking you the number of modules kan? Number of modules. So untuk case ni, lain macam mana lain? Pendapat yang lain. Nak dengar pendapat lain. Divenia.
Yes, Doctor. I think 32.
32. Means, so the answer is 32 round down lah. The reason? What is the reason, Divya?
Maybe
Same concept with the first
yeah.
one. Like that?
Same as reduce.
Okay. Okay. Nak dengar pendapat lain lagi. Farhana.
Yes sir, round down.
Round down juga. Sebab?
Sebab alasan yang sama.
Sebab sama dengan 1 dan 2 lah. Macam tu Okay. Syahira. Macam biasa lah. Syahira main nama mesti kena petik.
Dia doktor.
Macam biasa lah. Memang kena petik lah. Kau ingat kau duduk diam? Macam mana? Kawan-kawan, rakan-rakan seperjuangan kau semua kata 32 which is round down. What about you?
Saya rasa round down juga.
Round down juga. Kau ikut flow tu jugalah. Betul? Betul Ke ada pendapat lain? Tak ada?
Tak ada.
Yakin Okey. Kita tanya Naufal. Lama tak dengar Naufal. 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 Skip. Naufal. Ayuh. Kantoi situ, Naufal. Mak Kelvin.
Yes, sir.
Yes. Majority of your friends telling that we need to go round down and we get the 32. What about you?
Sama kat saya.
Okay. Apa lah? Tak ada pendapat lain ke? Aduh. Ezudin. Nak tanya semua ni. Ezudin tak ada lagi. 2 kali panggil Ezudin ni. Apa ni? Alia Ashifah. Tadi mula-mula panggil Alia. Closing kita panggil Alia agak. Alia.
Yes, saya sir.
Macam mana? Majoriti kawan-kawan kau semua kata 32. Round down.
Itulah tu saya round down agak saya.
Jangan lah. Please say betul lah. Aduh. Ahmad Daniel. Apa benda? Macam mana? Mana ni? Majoriti manusia mengatakan round down 32.
Kenapa?
Kalau kau mengatakan 32 juga, kenapa? Saya tak nak reason yang sama dengan 1 dan 2, tak nak. Nak reason lain. Cepat. Silap lah kau semua. Dah. Naga.
Sebab benda tu total.
Apa? Ulang balik.
Sebab benda tu total.
Sebab benda tu total. Lagi alasan lain.
And total.
Total lah. And total.
So yang pasal yang decide to meet yearly energy tu okay lah Zai?
Ulang balik. Meet?
Yang pasal meet yearly energy requirement.
Sebab tu round down. Ke?
Sebab dah.
Okay. Alasan kau tu. Okay, tak apa. Kau guna wording yang lain. Bagus. Okay, tak apa. Aku tanya orang lain juga. Ashraf Aziz. Ashraf. Close kan? Settle kan? Ashraf.
Saya tak tahu. Saya rasa round down kot.
Round down juga. Sebab alasan tak nak sama macam dia orang. Aku nak alasan lain. Bagi alasan lain.
Alamak.
Tak tahu?
Tak tahu.
Okay, macam ni. Like this. Okay, Muzammil. Lupa. I forgot to ask Muzammil. What about Muzammil? Ke tak ada dalam ni? Wilai lah. Okay, macam ni lah. Okay, let's say. Please focus. Okay, let's say. Okay, we round down. Alright, we round down. So means that we are going to buy, or not buy lah, we get 32 modules. Okay, 32 modules, and then we install. Okay. Do you think, okay, the numbers here, written here, 32.65. Okay. If we reduce it to 32, do you think we can achieve this? Ni, 10 megawatt hour ni.
Oh.
Ah.
33 je.
Why no? Why?
Because this is the third design sir tadi. Oh,
Third design lah. Betul, kenapa? Kau ni sibuk third design. Tak tahu. Saya tadi kalau kita decide to use 32 means that we are going to get 32.65 is the rated one for the 10 megawatt hours. If we round it down, we get 32. Can we get the 10 megawatt hour? Huh? Cannot. Why cannot?
Because annual peak sun hour.
Ulang balik. Again?
Berkait dengan annual peak sun hour kot.
Annual peak sun hours. Bukan tu.
Sebab equation dia in total dengan energy yield tu directly proportional.
Ulang balik. Energy yield dan juga equation dia directly apa?
Directly proportional. Kalau N total dia menurun, then E system pun akan menurun.
Yes, that's the answer. Not that exactly accurate, but 32.65 is that's why saya padam tadi. Saya padam tadi ada sebab kenapa aku padam maksimum tu. 32.65 is the number of modules that you need to have in order to achieve 10 megawatt hour. 10 megawatt hour of system, you need 32.65. Okay. We cannot do that because we cannot cut for the another one for the 0.65. That is why we round it up. When we round it up, it becomes 33 modules. If we get 33 modules, so this is the minimum number of modules for us to have in order to achieve 10 megawatt hours and avoid from being penalized. If we choose to round down 32, by luck, maybe you can achieve 10 megawatt hours, but by default, the design itself cannot push you beyond the limit. So you maybe get 9 point something. So that is the problem. We cannot achieve to the target, and then we will be penalized. That's why, for this case only, minimum numbers of module in order to achieve the energy requirement, you need the minimum numbers. You cannot maximum numbers. Maximum numbers is unlimited. But for you, it's minimum numbers. As soon you have the 33, then inshallah. So this is the minimum numbers that we can have in order to achieve 10 megawatt hours. Kalau get more than that, it's better lah. If you get more than that, it's better. If the voltage drop is lesser, it's better. But the minimum requirement is to round up. Then it becomes 33. Semua salah, semua fail. Semua salah, semua fail. Gitu. Habislah korang. Boleh? Boleh, Alia? Boleh, Alia?
Boleh saya.
Kena tukar pegangan lah. Pegangan kena tukar. Gitu. Nafal boleh, Nafal? Nafal tak ada lagi. Dah. Hafizah Ali? Saya rasa macam dah habis slide ni.
Boleh sir.
Boleh? Oh, ada suara. Okey, tadi tak ada. Okey. Habis dah slide ni sih. Yeah. Okay, last kata-kata akhir. In this module, we have determined the total number of PV modules that is required based on the selected sizing criteria, but the final number will be dependent on the selection of the inverter and the specific number of modules that can be connected in series and parallel to the inverter. This will be covered in the next module. So, based on three criteria first, then we have we can get the not rough number, the numbers of module, the maximum number or the minimum number of modules we can get. Then after that, the revision, there will be revisions of the number of modules after we choose the inverter. So that is the next step. Next step. So next step, we are going to choose the inverter. In order to choose inverter, there's a requirement there. Okay? Alright. I think thank you sudah. Any question? 3-4
Sir,
juga.
minggu ni ada quiz kan sir?
Ya. Oh, lupa nak remind Okay, this week
hari apa sir?
Okay, maybe I will open Friday night. Mungkin 8 malam. Mungkin 8 malam. Until Sunday night 11:59 PM. Okay? Quiz 2. Okay, and then cover only chapter 3. Not the whole chapter 3 lah, but chapter 3 lah. Only cover on chapter 3 lah. Kalam. Okay, in the kalam. Any question? Don't forget our test lah. Oh, lupa. Don't forget our test. Monday, 25 April 2022, 2 to 4 PM. Also, kalam. Okay. Given time 1 hour and 30 minutes, but there's a plus of several minutes for your uploading, for you to upload. Okay, to upload your PDF. Okay, please time yourself very well. 2 questions, and it covers from chapter 1 until chapter 3. Okay, until chapter 3. So means that the quiz 2 is the exercise for you. Okay, it's the exercise for you. The quiz 2 is not the it's not the what you call that?
Multiple choice.
Not multiple choice. It's the subjective one. So boleh dapat markah lebih lagi lah. Subjective. Dia bukan embedded lah. Bukan pilih. Okay, ni ada question. 3.40 juga. Syahira ada soalan? Syahira lagi ni.
Tak ada doktor.
Tak ada. Syuhada ada soalan? Syuhada. Tak ada. Oh, suara lain sikit Siti Fadila ada soalan? Tak ada Ganesh, any question?
No sir.
Owi. Selalu panggil Owi setiap kali kelas. Ada soalan?
No, sir.
No. Okay. Divenya. Question? No? Tak ada. Chai Kuan Ji.
Tak ada, sir.
Tak ada. Okay, kalau tak ada, thank you. All the best for the quiz 2 and test. But quiz is not big deal lah. Test. Okay, please score the test. It's open-ended. Open-ended lah. Open book. It's open book exam. But don't copy others lah. It's very clear for me to trace. Okay. Alright, thank you.